In this section, we'll look at the key characteristics of 5 classes or types of data services available in IBM Bluemix. First, we'll look at NoSQL database services. Then we'll look at SQL database services, followed by in-memory columnar database services, key value pair services, and finally, time series services. So now let's look at NoSQL database services. These are managed data stores that use non-SQL query languages or no query languages at all. They typically store data as a series of documents, so they're document-oriented. And examples of these types of services in Bluemix include Cloudant, which is an extension of the Apache CouchDB open source project, and MongoLab, which is based on MongoDB. Now let's look at some advantages of NoSQL database services. First, they're very flexible because they have no enforced schema, so your document structure can change at any time without having to modify your existing documents. So you have a lot of flexibility in terms of adding and removing attributes to documents as your needs change without having to affect existing documents in the database. Another advantage of NoSQL database services is that they typically scale horizontally on low-cost commodity hardware. And this is possible because in their design, they prioritize availability over immediate consistency. In Cloudant and Apache CouchDB circles, this is known as eventual consistency. And this actually works well for many different use cases. Let's look at an example. Consider Yahoo News, a very hot, late-breaking story that has lots of users commenting at the same time. So at any given point in time, you may have hundreds or even thousands of Yahoo users writing comments on this news story, and all these comments are being stored in a NoSQL database. Well, the key here is that it does not affect the integrity of the application if at any given point in time a particular user commenting does not have all the latest comments that have been made up to that point in time. That user will eventually see all the comments if they stay on the story and keep refreshing the page. The key here is that with a NoSQL database, having these thousands of users commenting all at the same time, the scalability will make sure that the database is available to all the users when they need it. But again, it does not affect the integrity of the application if at any given point in time a particular user does not see all the comments made up to that point in time. So that, as we said, that does work well for many use cases, but there are a few use cases where this does not work. Let's take the example of stock trading during market hours. At any given point in time, the price of a given stock is dependent on the last transaction. So consider the case where you have several different transactions that need to be executed. It's very important that they be executed in chronological order, but each one of those transactions need to have the results of the latest transaction in order to function properly. So if you were using a database that was horizontally scaled, many hundreds of low-cost commodity hardware servers, for example, you would have the problem of keeping all those instances in sync with the latest data. So typically for these types of applications, they use databases that use vertical scaling, large servers, and they minimize horizontal scaling in order to avoid the consistency problem. Now let's look at SQL database services. And these are just database as a service offerings based on traditional underlying relational databases. In Bluemix, examples include SQL database, which is powered by DB2. And in addition to the DB2 functionality, it provides high availability, automated backups, and ability to mask certain data as private. Another example is ClearDB, which is powered by MySQL. And then there is Elephant SQL, which is powered by PostgreSQL. Now let's look at in-memory columnar database services. These are in-memory data stores that organize data by columns instead of by rows. This proves especially useful for analytic workloads that require aggregation of a limited set of columns with a large number of rows. So consider a reporting application that needs to report on financial data for a given company. In particular, let's look at sales figures. So the sales figures will be recorded as a set of individual transactions that then need to be aggregated across different dimensions, like a time period by week or by month or by quarter or by year or by store or by region or by country and so on. But in all cases, we're talking about a relatively small set of columns and a large number of rows. So this type of workload is ideal for columnar database services. In Bluemix, the -DD service is an example of this type of service. It is powered under the covers by DB2 with Blue Acceleration, which is a set of technologies that came out of IBM research that specifically addressed the challenges of running analytic workloads within general purpose databases like DB2. And -DB also leverages compression so that more data can be stored in a given amount of memory, because remember, these types of services are memory-based data stores. Now let's look at key value pair data services. These give you efficient storage in memory and efficient retrieval of key value pair data. Each record consists of two values, a key and a value, and the keys work like indexes, making retrieval very fast. Examples of key value pair services in Bluemix include Redis Cloud, the IBM Data Cache, and the IBM Session Cache. Now these types of services are very useful for different use cases, but they are particularly useful for storing stateful information in horizontally scaled web apps. So this allows these app instances to remain stateless because they store all their stateful information in an external instance of a key value pair service. So for example, an app, e-commerce app, may have shopping cart information that it needs to maintain between requests. So by storing this in external service, these app instances are totally stateless, and an app instance can be replaced by another instance. So in the case where one instance crashes, another instance can take over from it right away without losing any application state. Finally, let's look at time series database services. These are managed data stores optimized for time series data. They enable efficient storage, retrieval, and querying of timestamp data. An example of this type of service in IBM Bluemix is the IBM Time Series Database service. This is powered by Informix under the covers. It can store time series data in up to 1/3 the space of other databases. It also provides several SQL extensions specific to time series data, so you can make some sophisticated queries along the time dimension. let's wrap things up with a summary of what we talked about. So we discussed the key characteristics of 5 different classes of data services in IBM Bluemix. We looked at NoSQL database services, which are document-oriented schemaless data stores that are optimized for horizontal scaling. We looked at SQL database services, which are services based on specific underlying relational database technologies. We looked at in-memory columnar database services, which are column organized data stores that are optimized for analytic workloads. We looked at key value pair services, which are fast in-memory data stores that are optimized for both storage and retrieval of key value pair data. And finally, we looked at time series data services, which are optimized for time series data.